We're going to do motion today, and the question is whether Father Universe moves. We're going to argue today that every atom in Father Universe, only has location. He looks at himself. Father Universe looks at himself, says every atom simply has location. And we say, yeah, but I saw you move because every atom moved to another location, then to another, and then to another, and then to another. And Father Universe doesn't know what you're talking about. What the hell? What do you mean? I only have every atom only has location. Every time I look at it, it only has location. And so maybe the problem is that we're not communicating with Father Universe. We are all living entities, and we have this memory, this device that records, previous locations. And maybe that's the problem. We remember the previous locations, and so we see this movie. But Father Universe is not a movie. Father Universe is a photograph. He only has location. Anyways, we're going to go into that. Then we're going to answer a couple questions regarding the rope model. But before we can before we can talk about Father Universe, whether Father Universe moves or has location or whatever, we need to look at another problem, a more fundamental problem, and that is, what is science? What is physics? And we seem to have already a major problem understanding what physics is and what science is, okay? What I'm going to do today, a lot of people won't like it, is I'm going to raise the whole board, okay? Everything that's been done from today to the past, to the days of the Greeks and even before, we're going to raise it completely. It's all been irrational, okay? And it's been irrational in great measure, because we have not defined what science is, let alone what physics is. We don't seem to know what physics is. And that's the argument today, at least the introduction to the argument. Okay, so let's start with this. This is, you look up the word science in the Google, you Google it, and you get this AI, which lately is very popular. Everybody consults the bots, right, to see what the official versions are of words or whatever they're looking up. It turns out all these bots, you have to keep this in mind. All the bots were programmed by mathematicians. And unless you understand that, there's a lot you're going to miss, okay? So make sure you understand that all the bots, the GPT and whatever, all these are programmed by the mathematician. They're putting the words into the bots, okay? So that's important to understand right off the bat. But this is when you put up the word science in Google, you Google it, that's what you get, okay? Here it is. It says the AI, okay? And it says science is a systematic way of what? Studying. No, in science, we do not study anything. You can study all day long, all week long, all month long, all year long, and it doesn't mean you understood. Okay, so studying is not part of science. We do not study in science. It's not an ongoing process, and that's where we already start failing. Any definition of any discipline within science that begins with the word study or studying, it's already, irrational, because studying doesn't guarantee understanding. And then you have knowledge, because science, derives from the word know, if you look it up. And this is our ancestors who screwed that one up badly. Science is not about knowledge. Knowledge is simply more firm, more fanatic belief, okay? People who believe something, well, they believe it. But people who know something, hey, you can't change their minds because they know it. Their belief is very, very strong. So knowledge is just stronger belief. And so we don't pay attention to knowledge in science, in genuine science, okay? The big one there is testable hypothesis. What do you mean a testable hypothesis? I thought a hypothesis was an assumption. You don't test assumptions, you concede them in order to understand the theory that it underlies, right? But let's continue. We have predictions. No, we don't. We're not astrologers. We don't predict anything in science. Science has to do only with the past. We explain things that happened, not predict things that haven't. Okay. Evidence. No, we don't use evidence in science. Evidence is what is used to persuade, to convince, to convert someone, to recruit them. Right? And so we don't use evidence in science at all. That's got to do with religion. It's got to do with persuading, having people change their minds, right? So we don't use evidence at all. We don't observe. We don't gawk. Why? Because observation doesn't mean that you understood, and people say, well, how can you know what you're talking about if you don't observe first? Well, you can have hypothetical situations. It turns out our blind sage, has never seen, and he was quadriplegic as well. He doesn't see or can't touch anything, but you explain the situation to him, or you describe a situation to him, and he's got to answer the question, the mechanism, the cause. Okay, so you don't have to observe in science. And the problem with observation really is that they turn observation into a proof, into evidence. They say the particle went from here to there. Well, how do you know it was a particle? Did you see it? And they say, we observed. Now, you did not observe a particle. You're making an assumption that it was a particle. That's the way it works in quantum mechanics. They did not observe any particles. They make an assumption that they're working with particles. So the word observe or observation are turned into weapons to try to force it upon you that they did see it with their eyes. Are you going to challenge what they saw with their eyes? No, they did not see it with their eyes. And measurement has to do only with mathematics, with mathematicians. We do not measure anything. Science is about something else. It's about explaining, not about measuring. Okay, you measure the table. Does that mean that you're a scientist because you measure the table? So this is where the problem is, that a lot of these words are used as weapons against the person who's trying to understand. Okay, and they say, "Whoa, we observed, we made predictions, and the prediction came true because we measured," and so on. All those words have nothing to do with science. That's why we're erasing the slate completely clean. Okay, we're saying none of that has anything to do with science. Okay, just in case, here's the Science Council. It has essentially the same words, so it's not like I just picked one out of nowhere. All of them have the same idea of what science is. They're talking about knowledge, evidence, predictions, experiments, evidence. None of that has anything to do with science. Okay, all the words that are underlined there. Okay, so, but I'm worried about this testing the hypothesis, the one there in the center. Hypothesis, do we test hypothesis? Is that what we do in science? Okay, let's find out what a hypothesis is according to these people, why they're going to test it. Okay, and here we have this this definition according to the official version out there. Hypothesis, a proposed explanation for a phenomenon. So we have explanation. And what is an explanation? A set of statements usually constructed to describe. So is an explanation a description? But what is a description? It's a characteristic and aspects to form a mental picture, impression, or understanding of something, right? And so the issue here is that, no, a hypothesis is not an explanation, because an explanation is not a description, and a description is not a hypothesis. In other words, it's not an explanation. In other words, what they're doing is going around in circles here. They say hypothesis is an explanation, which it ain't, right? And an explanation is a description. And so we need to distinguish what these words the differences between these words. We need to define what these words mean. Okay, and when you look it up, it says the following: it says a different meaning of the term hypothesis this is out of the wiki, by the way, is used in formal logic to denote the antecedent of a proposition. Thus, in the proposition, if P, then Q, P is what? The assumption. It's an assumption. And if you look at it further, you'll see it's a supposition. So assumption supposition is not an explanation. And so they have contradictions because they're defining it as an explanation, hypothesis, right? When later on they describe it as, or define it as, an assumption or supposition. And yeah, supposition, assumption, they're not explanations. You make an assumption so that people can follow your theory, founded upon that assumption. That's the way it works. And if you go back to the Greeks, here you have, the Greek, this is again out of the wiki, the Greek natural philosophy of classical antiquity. Formal attempts were made to what? Provide explanations. That's what they were trying to do. They were trying to explain. That's what science was. It was an explanation. They were trying to explain how this universe works. Explanation of events in the physical world based on natural causes. Yeah, they were trying to explain causes. That's how science started out. That was the idea. People want to know why things happen, how meaning why the universe works the way it does, the causes, the mechanisms. We want to understand why, this thing falls to the floor. That's what we want to understand. That's a cause, that's a mechanism. And that's not what we have today. In fact, we have no mechanism whatsoever for any phenomena involving invisible, intangible mediators. That's where the problem is. That's what we have to solve. And some people say, science is not about explanation. Science, meaning mathematical physics, right? Which is an equivalent of science in the minds of many people. It's got to do with descriptions, with mathematical descriptions. We measure, we have an equation, we're done. We're done with mathematical physics. And, here are some testimonies, if you want to listen to them. Here's one from a professor in Pennsylvania, and he says the following. He says, science doesn't explain, science describes. So the first thing you notice there, that there seems to be a difference between a description and an explanation. The second one is he's stating that science is about descriptions, not about explanations. So meaning mathematical physics, because that's what he is. He's a mathematical physicist. And so the question is, is that what science or mathematical physics is supposed to do? Physics, is it supposed to just describe and say, look, this is a description, mathematical description, and we tell you how, not why. Okay, that's what's at stake here, right? Okay, so there you have one testimony, a fellow who works at a university, right, or at least did work. Here's another testimony. This is from good old Nobel Prize Richard Feynman. He said the following. He says, we choose to examine a phenomenon, the double slit experiment, right, which is impossible, absolutely impossible to what? Explain. He's talking about explaining it, okay, in any classical way. Nobody can give you a deeper explanation. He's talking about explanation, and as he says, of this phenomenon that I have given you, that is a description of it. That's all he can give you. He can give you a description, a how. He cannot give you an explanation, a why, the cause. Okay, so we're distinguishing between explanation and description. That's the first issue. The second one is they say we don't do explanations, we do descriptions because, as he says further down the line, says theoretical physics has given up on that. In other words, the mathematical physicists, they cannot explain anything. They've given up on that. They've given up on trying to explain. And so they've reverted, they changed the rules, they changed the purpose of physics, and they say from now on we're just going to describe. We're no longer going to try to explain. Okay? And so, we have a problem because there's a disconnect between what physics started out with, what science started out with, which was trying to explain things. And these people are now saying, hey, we've given up on that. We don't do explanation, we do descriptions. Okay? And so here I can give you my version of that. Here it is, the scientific method and the science that we propose here, what we call rational science. Rational explanations. That's what science is. Okay, so if you need to have a rational explanation. If it's irrational, it's not an explanation, let alone science. Okay, and so what we get out of mathematical physics are irrational explanations. That's where we stand today. All we get is irrational explanations, and people are kind of sick and tired of that, and so they kind of tune out and they don't watch a lot of this stuff. They become disillusioned, I guess, with science because all they get is black holes and dark matter and dark energy and Big Bang particles at two places at once and all this other nonsense. And they say, look, I don't want to listen to that anymore. It doesn't make any sense to me, right? So they tune out. And now we're saying science is rational explanations. That's why we have to erase the board completely because somewhere we went wrong, okay? Somewhere we made a wrong turn in the history of science, okay? And there you have, what is a hypothesis? It's not an explanation, not a tentative explanation. It's identify objects. You have to have objects, definitions, and the initial scene. Those are assumptions, okay? And that's what you're going to base your theory on, which is an explanation, a physical interpretation, okay? So that's what we're proposing. That's why we're called rational science, because we distinguish what we do here with what the mathematicians do, which is irrational science, mathematics as we call it, which is, they don't even have a hypothesis. They don't have assumptions. They start out directly at a theory and say, let me tell you my tentative theory. Theory of what? I haven't seen, the objects yet. I don't have your definition. I don't have the initial scene. And they already start in the middle of the film giving you their theory, their explanation. And they say, well, it's a tentative explanation, so we call that a hypothesis. Once we prove it, or we have more evidence, we have more measurements, more equations to back it up, then it becomes a theory. And when the democracy, sets in and most of the mathematicians believe in the theory, it becomes a fact. And they shove it down your throat. That's science in a nutshell for you today. And we're saying all that is completely misconceived. It's got nothing to do with what science is supposed to be, what physics is supposed to be. Okay, so here we have the differences between the mathematical method, mathematics, and the scientific method, what we propose. You can see the hypothesis is totally different. The hypothesis in mathematics is tentative explanation. There is no provision for assumptions. They say we observe, we hypothesize, they already have a theory, then they start making predictions, I guess consulting the crystal ball or reading your palm, I don't know what they do. Then they do an experiment, they measure, they formulate an equation, and then they start trying to prove to colleagues, right, through what they call peer review, right? The colleagues try to falsify your theory because they have a better one, or they have an alternative one, or they're skeptical about your interpretation, I guess. And if you happen to convince them, then you win a prize, they all vote for you, and you go on the talk circuit. Yeah, none of that has anything to do with science. That has to do with convincing, persuading, recruiting people to your way of thinking. No, the scientific method is objective. It's a hypothesis, is made up of the assumptions. The assumptions include the objects, for the purposes of physics here, right? The objects that you're going to use in your theory, the definitions, hopefully they are rigorous, right? And the initial scene. You start at the first frame of the film, okay? Then you explain your theory, okay? The physical interpretation. Okay, so you can see there's a difference between them. So we're proposing something totally different for science, let alone physics, which is a branch of science, right? Okay, so there's one person out there in the Stack Exchange, one of these places where mathematical physics spreads its word, okay, the Stack Exchange. And a fellow says the following, this is a lot of mathematicians have the same way of thinking. Something worth noting, science never describes the true reason why something happens, meaning explains, right? He's using the word describe when he means explain. It concentrates on what? Predicting the effects of what happens. Okay, so they're going to predict, and I guess that's a description, but he's talking about explanations. Okay, because he says, when one asks science why, meaning explanation, right, we answer by showing a deeper, more powerful model, which is a description. A model, unless you explain the cause, so far you only have a description. Okay, if you want the real reason, meaning cause for gravity, right, not reason. Reason is what is purpose. It's part of philosophy. Why someone does something. That's not the case with object, with things. In the case of things, we don't use the word reason or purpose, which is something which belongs to humans and to living entities. We use the words causes and mechanisms, which are the words appropriate for physics. Okay, so we're not talking about reason for gravity. We're talking about the cause of gravity. And turn to philosophy or religion. They believe causes belong to philosophy, religion, ontology, any of those, semantics, right? They'll dare to try to answer such ontological questions. And is this guy right? I mean, is this what science is supposed to be? Science is supposed to be just descriptions, predictions, no assumptions, right? And no explanations or irrational explanation. You don't like my explanation, go to philosophy, go to ontology, and they'll try to answer your question. Is that how science is supposed to work? Is that what physics is supposed to be? Here we have, this thing. It's a straw. Okay. Straw falls downwards, and that is the cause of that is a philosophical question. It's not a question of physics. Does that ring a bell to you? Is that correct? Does that sound wrong? Is there something wrong with that? Okay, so let's find out what they do today. Here you have one fellow. His name is Neil deGrasse Tyson. He's a famous showman, right? He's a so-called physicist, really a mathematical physicist, a mathematician. And what he does is he does explanations on his show. And so they asked him, I think it was on Joe Rogan's program, and he asked him, what is gravity? Can you explain gravity? Can you explain the cause of gravity? Why? Right? Not describe how. We mathematicians can do that. Can you explain why, the cause, the mechanism of gravity, how Father Universe does it? What's the mechanism? What's the trick, right? And this is a summary of what he says. He says, science can describe why gravity works, not why, how. So he's using describe to say why. Okay, he's confusing description with explanation. Why has to do with explanation. Describe has to do with how. Okay? In mathematics, we describe how and believe we understand why. That's where the problem comes in. He says the how is a why in the religion of mathematics. Okay? Mathematics, how is equal to why. Mathematicians describe how gravity works. Okay? Gravity, what is it? Curvature of time. Called space-time, but it doesn't matter. When we put curvature of time so that people are aware that these people are saying they're bending time, if that makes any sense to you, okay? And because when you say space-time, people say, well, maybe it's an object, four-dimensional, I can't imagine, okay? But when you say just time, then it shocks people. It hits them in the eyes. And what do you mean time? How do you bend time? And that's what they're saying. They're bending time. And but that's an explanation. That's a physical interpretation when you say, I'm going to bend something. Now you're giving a physics. Now you're talking about how. You're not saying I measured and this is how many meters, how many pounds. This was the distance. This is how much time. We're not saying that. We're saying we're bending something. Now we're talking about physics. Now we're talking about a physical interpretation. That's no longer a how. Now it's a why. Okay, and here they go back and forth with all these things. And so he's talking about a cause, a mechanism, a why, an explanation, a physical interpretation. Right? So why does matter curve time? Rogan asks him, and he says, we're still working on it. What does he mean by that? He puts it off. He puts the question off. He says don't ask that question anymore. We're working on it. And so he never answers the question. The question is, why, what causes gravity? And he says it's curvature of space-time. Well, what compels, these number lines to bend? And then he said, we're working on that. No, they're not working on anything. There's no way you can answer because he just gave an irrational answer. That's why. That's the purpose, the reason behind that. He gave you an irrational explanation, and when you call his bluff, he says, we're working on it. Sometime in the future, we'll give you an answer. No, they're not working on it because mathematical physics, does not work on whys. So they will never give you an answer. And then he comes into another show and says exactly the same thing, and so on and so forth. Okay, so we've got a problem with what these people are doing, giving this type of information to the public. Okay, that's where the problem is. And here he is, listen to his own words. It's not like I put words in his mouth. You're going to listen to him now. Okay, so this is what he says. Okay, here goes. Listen carefully.
Science can describe how gravity works, but can they describe why it works? So this is the how-why duality here. In science, if we can describe how something works and predict its future behavior, we claim to understand it and we move on. There's a point where it's not especially productive to continue to think about the world that way. When you understand the how enough, are tantamount to having answered the why question. I can describe what gravity is doing. I even have a mechanism for it. Gravity really is the curvature of space and time. Movement of matter on that fabric of space and time, we call gravity. Why does matter and energy curve the fabric of space and time? And I don't have an answer for that. Why does matter and energy curve space and time? Okay, that's a frontier. We're still working on that.
So, did you understand the cause of gravity, the mechanism of gravity? No, in the end, he has no answer. He's telling you it's the curvature of space-time, curvature of time, the bending of time. It's an irrational answer. So they ask him, what bends time? How can you make sense of that? He said, we're working on it. Ask me that in 100 years. He's putting it off. He has no answer. But the important part here also, in the background, is that he's trying to answer a why question. He says they did answer a why question. It's a description in which they turn into a why, into an explanation, into a physical interpretation, and that the mathematicians are satisfied that they answered the why question with their description when they didn't. Okay? And so they go back and forth between this how and why. And they work on the hows. They say they know why, and when you question the why because it's irrational answer that they gave you, they say, we're working on it. Put it off into the future. Don't ask that question again, please. Okay, but here we have another fellow. His name's James Beecham, and he tells you that these people do work on whys or are interested in whys, okay? Just like, Richard Feynman said, they gave up on the whys, but they're interested. That's what physics was all about the whys, okay?
What causes gravity? So physics, as you know, this is the type of question, what causes gravity? This is the type of question that keeps physicists up at night. Because physics is, among other things, as you know, the search for mechanisms, the reasons or explanations for why certain things happen the way they do.
So, do mathematicians, meaning the physicists, who call themselves physicists, are they interested in the whys? Of course they are. That's what physics is about. Why? Not the math. It's the physical part. How this universe works. What is reality? How does reality work? We want to understand how gravity works. We want to understand how light works, how magnetism works. That's what we want to understand. And these people, as Richard Feynman says, they've given up on that. They want to understand it, they don't understand it, so they give you a description in lieu of an explanation. Okay, that's where the problem is. Okay, but what's the way to destroy their argument? This notion that mathematicians, physicists, right, as they call themselves, we only do equations, we only do numbers, we do calculations, and that's our realm. And so don't ask why, don't ask for physical interpretations, go to philosophy for that. Well, that's nonsense. And here's proof, evidence, okay? Let's prove it. Proof and evidence, that's what these people believe in. Okay, so here, let's provide evidence. Yeah, you have all these people. You have Tyson there, Sean Carroll, Carl Sagan, Brian Cox, Brian Greene, any of them, Hassenfelder. What do they do every day? On their shows, on their documentaries, on their interviews. What do they do? Do they do equations? Do they put an equation there and say, look, this is the equation so-and-so, and this is equal to this other thing. If you take, the limit of this, is that what they do? Do they put equations on their shows, on their documentaries? Do they even do experiments? Say, let me show you an experiment that proves my theory. No, what they do 90 to 99% of the times, maybe 150% of the times, right, is physical interpretations. They're doing explanations. They're trying to explain to you how this universe works according to the mathematical physicists, mathematicians, right? They're trying to explain to you. They're giving you physical interpretations all day long. I mean, go to any other sites and you will not find equations, because if they did put equations, nobody would watch them. They wouldn't have a single hit. Everybody would run the other way and say, no, I got better things to do. Okay, so all these people do physical interpretations all day long. Then when you say, look, give me a physical interpretation for gravity, oh, we don't do that. We do equations. Well, we got a contradiction, because that's what these people do every day. That is their line of work. These so-called physicists who are online, who are trying to convince the public that they're correct, that they're right, that their theories are proven facts, right? That they know. What they do is physical interpretations all day long. That's 100% of what they do. But then they deny it when you say, well, you do physical interpretation, can you tell me why, what causes gravity to work or magnetism to work? Oh, we don't do that. Go to philosophers. Well, if you go to the philosophers, I mean, are they the people who are supposed to answer these questions? Why did the physicist, the mathematician, why did he attempt to answer a why question, a physical interpretation type of question, if later on he's going to say we don't do that? I mean, is he a philosopher? Does he have a degree in philosophy? Is he an expert in philosophy? Why are they giving you physical interpretations if it's not part of their line of work? If then they send you over to the philosopher and say, go ask them. Turns out you go to the philosophers and they get their cues from the mathematicians. I mean, go to Stanford Encyclopedia of Philosophy, right? And any analysis they make of things related to physics, they all come from the mathematical world. And so the question is, they try to interpret and they give the same interpretations as the mathematicians. So there's no differences between them. And they tell you it's irrational, we don't understand it, but that's what mathematics tells us. So they all give you the same answer. So whether you go to a philosopher or the so-called physicists, the mathematicians, you always get the same answer. And so who do we have to go to get an answer to the question of why? What causes something to happen? And the answer is there's no one out there today. Okay? Mathematical physics does not give you why answers, rational why answers. And the question is then whether mathematical physics has anything to do with physics, let alone with science. I mean, is it science? If science is rational explanations, mathematical physics has nothing to do with science, let alone with physics. That's our position here, right? And so here we have a definition of physics. What is physics from the Wikipedia? It says physics is the scientific study, again, study. We don't study anything in physics, of matter, its fundamental constituents, its motion and behavior through space and time, and the related entities of energy and force. Physicists generally, this is under the physicist article in Wikipedia, generally are interested in the root or ultimate what? Causes of phenomena. So if they're interested in causes, it is part of physics. But they have these contradictions. They say they're interested in causes. Then when you talk to a mathematical physicist and put him against the ropes and begin to pummel him because he gave you an irrational explanation, it says, we don't do causes. Go to the philosophers. So we have this constant contradiction between, what is physics? It's like they don't know what the subject matter of physics is. Here it says that physics deals with causes. Then the other one says, we just study, we do ongoing work, we do descriptions, we do math equations, and we don't do causes. And then for physics, you look it up, it says causes. Okay? And it says, theoretical physicists specialize in modeling physical systems to rationalize, explain natural phenomena. So do they do explanations? Do they do causes? Do they do physical interpretations? Or are they just going to describe mathematically what is physics about? And so down at the bottom we have little old me there, science, rational explanations, physics, rational explanation, which is a branch of science, right? Rational explanations of causes and mechanisms. Now we finally have a definition of what physics is. And of course, those two definitions, they exclude all of mathematical physics, especially quantum mechanics, general relativity, and string theory. None of those have anything to do with science, let alone with physics, because they don't have any rational explanations. Okay? So here are my conclusions for this segment, which is the introduction. Conclusion: mathematicians who label themselves as physicists have yet to define the subject matter of physics unambiguously. Do they do explanations? Do they do physical interpretations? Do they do causes or not? Okay, that's the question they have to answer. They have to answer that up front before they begin to talk in their programs, in their interviews, in their documentaries, because that's what they do in all those places. They talk about explanations, okay, about physical interpretations. Celebrity mathematicians, what they do, most of their shows, 90 to 99, say even up to 150%, they're explanations, physical interpretations. Okay, that's what they do in all their documentary shows, interviews, etc. When confronted with their irrational physical interpretations, the mathematicians dismiss explanations as philosophy. Go to the philosopher, don't ask us. So when did they attempt to do explanations? These are not part of their job descriptions. If it's not their line of work, why are they giving you explanations on their shows, on their, during their interviews and in their documentaries? Do they have degrees in philosophy? And if not, then they should stick to math, numbers and equations, and leave physics, alone, right? Who should answer such qualitative questions if not the noble discipline of physics? Okay, so we have a problem because right now we have no definition what physics is, no unambiguous definition what physics is. Does it do, especially, does it do causes, does it do physical interpretations or not? It's black or white. Either they do or they don't. Okay? If they do, then they have to come up with an explanation, a physical interpretation for gravity, for magnetism, for whatever. If they don't, then why did they attempt it in the first place? Why is it that that's what 100% of what they do on the, in YouTube and all the popular sites when they talk to the public? And are they, philosophers? Are they experts in philosophy if they dismiss that as philosophy? I mean, why are they doing this if it's not their line of work? And if not them, who? That's very simple. So those are the questions we have to ask any mathematical physicist, mathematician, right? Before he begins to talk. That's got to be settled first.